So welcome everyone. My name is Zihen Sun from George Mason University. Um, yeah, I'm co-hosting this session with my colleague Chen Huang from Eastern Tennessee University, State University. Sorry. And Dr. Tao Hu from Oklahoma State University. Um, we're focusing on how to realizing the practical AI in the earth science. We're focusing on like the actual practice use cases of AI in the real world scenarios. And first of all, the first part of the session, um, Chen and Tao is going to introduce their like a ECIP lab projects, the results. They are working on creating the dashboard on flooding in the Central Appalachia. And the second part of the session, we will talk about like what's the most interesting ideas you want to work on in next year. Actually, not that in this year, as a community. So we can just start working on that because I think paper writing probably is the most direct way to help us to navigate how to implement AI in the Earth data science communities. Next slide. Yeah, so before we go into in 2025, I want to report to the community about our achievements in the past few years. We actually have done a lot of amazing things in this cluster. The machine learning cluster has published 2 papers, both review papers, and actually it's a Nature. The paper's Nature is actually trying to create some like white paper and also like provide some overviews and ideas and lay out all those challenges and the issues that you have to be aware of if you want to work on AI in this domain. So the first paper we published, I think this one was like 3 years ago now. It was published in 2022 February. It's a very it's actually a very high profile paper because it has been the most cited paper of that journal for 1 year now. And we actually has 10 or 20 more citations as second place. So it's pretty high profile paper. And it's also the most downloaded paper for almost 2 years now. So I think it's instantly actually the most downloaded paper of the entire journal since it's published. So actually, our contribution to the community is it's actually pretty well received by the community. I think that this paper actually helped a lot because I heard a lot of people's voice about like, yeah, this paper actually clarified and made the problem seems more clear and people just don't have to, wandering around about what AI can do or what is AI actually from perspective of most people will never actually interact with this concept. Next slide. And yeah, last year we published another paper. It's also a machine learning cluster community effort, working together with ESDS WG working group at NASA. Also, we involved officials from the NOAA and other federal agencies, and the university is a nonprofit agencies. And this paper actually talking about how to, going towards the actual practical AI, which is most people actually only doing prototype, but how to make it practical in the real world. So we talked about those challenges and what we should do next. So this paper is actually pretty, made a lot of noise. It has been downloaded more than like 1,600 times, but the average access number for that journal is actually 200. So this is actually quite wide overarching like very high profile paper as well. So we hope that we can continue this journey and make contribution to this field. And after all this discussion back and forth drafting revision of the paper, we think that we can actually get better understanding of the field at this point. So I think all this effort actually worth it. And I hope that if you are interested, you can just feel free to join us. We have the monthly meeting, I think it's first or second Friday at like 11 a.m. Eastern time. So yeah, feel free to join us, and we are thinking about what next paper idea we should work on. So next slide. Yeah, and besides the paper writing, we actually invited a lot of speakers. All these speakers actually are intensively working on AI in this field, like and talking about like how to solve the AI problem with the team science. Like she mentioned like the AI is different. It's different from all the previous like research problems. It's actually too giant tech. We have to collaborate to do this. And then talking about how he did the research on AI on CI's mapping at ECMWF. Herman is already a very established figure in the AI research in the hydrology. Benedict is actually a student at MIT. So he also talked about like, he actually has a lot of insights. His insights actually very helpful for me personally. He talked about how do you do the forecasting for like next maybe I think 100 years or something, and long-term forecasting, short-term forecasting, and graded like what's the problem with their AI results. Very helpful. And last month we invited Sinenka to talk about the quantum AI research he did at NASA Goddard. So he has a lot of very good, very good insights there, and inspired a lot of discussion there. So you can go to our meeting notes and see all these talks and their meeting notes. Next slide. Yeah, I think that's it. So I'm gonna give it to you. So Tian, you can take it over. Thanks.
Thank you, Jensen. I am Qian Huang. I am a research assistant professor at East Tennessee State University. And I'm here to present leveraging generative AI for automatic flooding dashboard in Central Appalachia with Dr. Hu. So this is last year's ESIP lab small grant project. And this is actually, we got the funding notification 2 weeks before Hurricane Helene hit us. So, so it's like a very insightful decision for funding this. This project aim is to try to leverage the generative AI to enhance the multi-source data collection, processing, and integration, and automate the dashboard creation and maintenance process. And we use the flooding dashboard in Central Appalachia as an example. So the on the right map, the yellow part is the Central Appalachia, and we always think Appalachia is not like I live in Appalachia, and I live actually here, Johnson City, Tennessee, and before Hurricane Helene hit, we have 2 years ago we have another big flooding in Central Appalachia, and it hit us very bad, and people didn't think about a big flooding in the Central Appalachia until it happens, and which was devastating. And so actually we have a picture to show in late July 2022. There was a severe flash flood and damaged over 100 bridges and 10,000 homes and resulted over 40 deaths. And this is a picture that taken a day after the flash flood, and showed the school bus was caught up in the flood water. And the Central Appalachia area is like 82 counties in eastern Kentucky, West Virginia, and Southwest Virginia, and then northeast Tennessee. So which is being particularly vulnerable. And I also have some pictures about Hurricane Helene. In last September, it caused devastating flooding in Central Appalachia, in South Central Appalachia. and with a lot of rains, it's actually looked like this. And even so, at that time, the highway stopped working, was all flushed. And then even it took us 3 months, 4 months to recover the highway. The last week I drove to Asheville, it's still only one lane is open. It's still during recovery process, and the mud and the breaking bridges is exactly like this. And I have colleagues who live in Asheville, lost their communications for a couple of days, and they do not have clean water, and they didn't have internet for several weeks as well. So they have to evacuate to other cities in North Carolina. So the situation was very bad, and more than 200 people died. Road bridges destroyed, and it's a devastated area, also predominantly rural and lower income, which makes the situation very bad. GIS dashboard could help monitoring the process and check the socioeconomic status of the county. And I've made some environmental GIS dashboard before. For example, the Challis air quality dashboard, which visualize the current air quality in Challis community at that time. However, developing GIS dashboard requires professional training, and it's very time consuming and label intensive. And if we to solve that case, my colleague Dr. Hu suggested we could definitely use some generative AI to help develop the GIS dashboard. It tried to automate it as much as possible. And also, we want to present this research to gain all of your feedback on the product we have right now. We have a draft one, and we do want to get a lot of like feedback and to communicate to get what we need, what we're missing, etc. So for the generative AI part, I will let Dr. Hu to talk about more.
All right. Thanks, Jan. So in the following slides, so by the way, so my name is Hu, and currently at Oklahoma State University. And in the following slides, I'll briefly introduce the main techniques that we are using to develop the automated dashboard, especially for these flooding case studies. I believe most of you have been very familiar with like generative AI, so I will briefly introduce it here. So generative AI refers to like artificial intelligence systems which can generate new content such as text, image, or even the geospatial data. And many different kind of models has been used to build a generative AI, such as transformer models, which has been used by ChatGPT and BERT, as well as like diffusion models, which has been used for by stable diffusion data, as well as like GAN models. So all these kind of models, basically we can call it like foundation models. So the foundation model is kind of backbone of the building like generative AI. And the diagram on the right shows like the workflow of foundation models in geoscience. And as you know, the foundation geoscience models, they are capable of tackling some challenges in multimodal and multidimensional, like the GIS or geospatial datasets, with like in the format of like text, image, or numeric, or in the audio and even the video inputs. And with the foundation models, you can employ like scientific representation of geoscience domain knowledge that enable us to engage in reasoning process and provides insights of geoscientists. And also the key benefits of using this foundation model in geoscience is scalability and generalizability and dynamic interactions and flexibility, high flexibility. Next slide, please. So actually, so in this project, we focus more on like large language models, basically for like text, the data analysis. And there have been many existing large language models, such as GPT, Google Gemini, and Meta Llama, and a new open source tool named DeepSeek, which has come out our attention recently because it performs much better than existing large language models, and it is developed by a Chinese company. And this kind of large language models has been assisting like can be used in many different GIS applications, such as automated geospatial data processing. It can assist in automating the collection, cleaning, transformation, and analysis of geospatial data, reducing manual efforts, and improving the efficiency. And the other application could be like geospatial data discovery and recommendation by providing efficient intelligent search, recommendation, and metadata generation for geospatial data sets. And last but not least is like automated report and GIS dashboard generation. Basically, with the large language model, it can streamline the process of generating reports and dashboard for spatial analysis and enabling real-time decision making. And on the right is kind of example of using like the ChatGPT to automate GIS data processing and visualization. And this is developed by Dr. Lee in Penn State University. Next slide, please. All right. So in the early stage of large language model, reasoning is like significant limitation. But recently, like capabilities in large language models has been addressed by many different models methods. And one of them is chain of thought, so which is a technique which allows like large language models to break down very complex problems into small problems or intermediate steps. And in GIS, it has we can use like this chain of thought framework to do a lot of apply this kind of framework to resolve many GIS problems, such as route optimization, then use then cover classification or change analysis. And this is a example here is about like when we calculate the flood risk, we can use this kind of framework to like first step is to understand and retrieve the historical like flood maps. And then the second step is identify at-risk areas based on the elevation or the other like environment data or physical data. And following that is to have like cross-reference with population density data. And the last step is to generate a final risk assessment. So all this process can be done within this train of thought framework, as well as the integrated with the large language models. And this is a framework. This is a key framework in our project. Next slide, please. So how do we can efficiently develop this customized the large language models as well as like implementing this train of thought framework? And NameChain is the one that we use. And it's a very popular like framework, allows developers to integrate large language models with external tools and APIs to build AI-powered applications. And the key feature of this kind of framework is that it can integrate different kind of additional large language models like GPT, Gemini, or Llama. And it can also develop the agent-based AI workflows to automate decision-making and as well as like AI agent development. Of course, it can also use to support different kind of different type of data, text, image, and structured data, unstructured data. In addition, it can use to like improve and your responses based on like improving the structure and optimize your prompts. Next slide, please. So based on these key techniques, and we develop this kind of framework for this project. And on the top, you can see we have different like data sources from LOA, from USGS, LASA, as well as socioeconomic data from Census Bureau, and some health data from CDC and HRSA. And with these data sources, we leverage the large language models as well as some GIS the packages to develop different kind of tools automatically, such as like loading different satellite image data, as well as like geoprocessing tools, buffer analysis, over analysis, and the raster analysis, and so on and so forth. And by taking advantage of like LangChain and ChatGPT, and we can split some kind of complex task or questions into smaller like pieces or small steps, which can be implemented based on the tools that we developed. For example, we have the example here. So we can maybe user have a query, find all the hospitals within 1 kilometer from the flooding zone in Central Appalachia. And with this technique, you can split this query into several steps or several actions here. So for example, the first action would be read the flooding data from LOA. The second action would be conduct spatial buffer analysis based on the hospital data, and as well as the flooding zone. And action 3 is to, so this here, the action 2 is conduct buffer analysis based on the flooding zone. And then it was to read, action 3 is to read hospital data from HRSA. And action 4, or the fourth step, is to do the spatial overlay analysis. After all these steps, we can get the final answer. So find all the hospitals within this 1 kilometer buffer zone from the flooding area. And this is one typical one example of the question that we can address using this framework. And on the right, it shows more questions that we can address, and also which are also urgent for local communities to understand more about what should I do during maybe flooding or any other kind of nature hazard. For example, like, do I need to buy a flooding insurance? Where is the closest emergency shelter to my location? And how can I get there? And which neighborhoods near me were the most damaged? Should I stay away from the certain areas? And how can I like find help with food, water, and medical supplies? And where should I go first? So all these questions can be split into smaller tasks and smaller tools that we developed based on this framework. It can help us to automate, answer, and analyze and process the data efficiently. And here we give next slide, please. And here's actually, so currently we are still in the testing phase. So here's this kind of example. We have like query. So I'm currently in Stillwater, and please show me all the mental health facilities within this 50 kilometers. So once I give kind of query to the framework, and then the framework we have developed, and then it will split this kind of query to several steps. So the first step is I need to gather user's current location. And then the action is to call the gather user location, like the tool. So this tool will do the geocoding and to convert the current location Stillwater into a longitude and latitude location. And second step is to take this kind of location as input, and then we'll load the mental health facility data. And then the output for this one will be the GeoJSON. And third step is to use the user's location as well as like mental health facility data, and to do the calculation and to find the closest, or to find all the hospitals within this 15 kilometers buffer zone. And the last step is we can visualize and create maps as shown on the top. So this is final outputs. So basically we just need to give this kind of prompt, and then we automatically generate it by our framework, and we can get final answer outputs as shown in this figure. So there is everything can be done automatically without any kind of manual efforts. All right, so Chen, I think yeah.
Great, thank you. So that's the ideal. We want to make it happen. But right now we do created we use a traditional way to create a dashboard, a flooding dashboard. I'm gonna copy this link to everyone. And I'm gonna do a demo of the flood monitoring dashboard in Central Appalachia we currently created. So this one, I did use the ArcGIS story map to create this. And on the left side, you will see the brief description of the project, the flood monitoring dashboard in Central Appalachia. I know some of you are from the Appalachia region, and I know most of all of the ESAP community is the best community to talk about this kind of product. And we do want to hear about all your opinions. Is good or is bad? What additional thing you want to watch? You want to find here? And we do currently Central Appalachia, and we do want to expand this project to South Central Appalachia as well. So while I do the demo, you can play around it, or you can just look at me to playing with the demo, and you can see what do you like, what do you do not like. Okay, so we currently have 19 tabs, and each tab will have show different information. The first one, we have definition, additional resources, and the citation to show what variables we currently have. We also have additional resources to include something else. For example, we have a real-time problem and outage report. So here you can check, okay, in the area close to me, what's the outage reported? AT&T outage reporting last 24 hours. So this happened pretty often recently, especially since I'm in Johnson City and it's winter advisory, it's cold weather advisory recently. And my phone sometimes lost connection. And during the flooding scenario, it will be worse. So we do have those kind of information to show the real-time problem and outage. And then we have community profile. Community profile, we show the county demographic and social economic status, because a lot of counties that experiencing devastated natural hazard effect are those rural and underserved community, and we do want to show a profile of each community to let the either the community people leader know or the policymaker know how to allocate fundings, etc. For example, this one has a percentage of age group, and have race, gender. We have economic distress status, economic status, and their phone services like broadband access, no phone service, etc. And we do link to some other outside website, for example, famous National Flood Hazard Layer, to show the detailed information of the flooding area. And we have USGS Water Watch. This shows the real-time flood and high flow conditions. And we have USGS hydrology data set. And this one can show the stream flow status, the real-time stream flow status, and about flood stage. Like this area is lower, pretty dry, and some are normal, and some pretty. I saw a blue actually in the morning, and you can literally monitor the status of those areas. And then we have file stations, geocoded. So we want to provide the community, or either the decision makers, some resources to allocate their platform to show their resources. We have file station. We have flood inundation map service that shows the river gauge. This is from the National Weather Service. And we have the waterways, OSM, the waterways, stream, river, and those, like, for example, those areas of, or all streams, consider like those areas will be very high potentially flooding areas if we get higher than normal rain. We have glide report. Right now, it doesn't show flooding, but they do show some wildfire in Los Angeles right now. And we have something I added is the live camera, traffic camera, and local road conditions because I'm in Johnson City and I do want to travel to Asheville sometimes, which is like affected by previous damage or the live traffic. You can literally see the live traffic camera, pretty live traffic camera through this website. And we do have communication access that geocoded all the secular towers, the phone service towers. If we lay it with the flooding area, like Dr. Hu said, we can say, okay, where has been affected. And we also have household with no phone services. Because during disaster time, you do want to contact your friends, your colleagues, your families to let them know. The no phone service this areas, like even it's without flooding or any hazard, those areas still have pretty high percentage of the household with no phone services. Because of the landscape in mountain area, when you drive to certain places, your phone is out of service at all. And that will create an extra challenge during the during the disaster time. And those are like all flooding related. We also have some community socioeconomic status related. We have the total population and the population density to show like kind of urban rural areas or areas underserved. We have the race, we have sex, the gender, male and female in each area. We have unemployment rate, poverty rate, economic distress area. This is we got mostly from the if it's a combination of the urban rural status and other information. We have labor force participation as well as a kind of employment related. And we are also adding more healthcare access as well. One example is hospital. And we do want to add, and during the hurricane time, the 3 hospitals near me are all got evacuated. So this layer can also layer with the flooding zone area to see the impact and to provide some resources for the hospital like management to decide if they need to evacuate the area or not. So this is the traditional way we make it, and we are trying to, so we're at the testing phase to use generative AI to improve the creation and maintenance process during the later process. So this is a quick demo of the flooding dashboard. And the next step we're gonna do is we are gonna add the generative AI in it to try to expedite the creation process. And we also want to have used this platform as a community engagement place, because I know all of you are like expert in some area, and we do want to get some of your feedback to improve this, and we want to make this dashboard co-developed instead of just we make it and show it to you and you try to see if you can use it or not. We do want to first of all engage you in the develop phase and also engage you in dissemination phase and the maintenance phase and future use. Okay, I'm gonna stop here for a second and ask if we have any questions for everything we just mentioned. No questions?
Yeah, I think we can just bring the question to the breakout. If
Okay. That's perfect. So as I just mentioned, we do want to give some ideas about what do you think about this dashboard. We're gonna have a breakout room, like around a 15 minutes breakout room. You can use some time to explore it, and don't feel obligated to talk in the disc. But we do encourage you to talk in the breakout room. But if you just want to be there and listen, that's totally fine with us as well. But we do want to collect some feedback and see if you want to co-develop this dashboard together. That's a great question. I do want to, so this dashboard, we just finished develop this week. And we do want to share this with the local emergency planning and response organization and see what additional data or map they want to see. And this is mostly for Central Appalachia. And we do want to expand this more to cover Asheville in this dashboard and send it to actually I am in Johnson City and it's right close to Elizabethton and Irvin. I literally is like 20 minutes away from them. So I am definitely going to share. Oh, great. I'm definitely going to share this with the emergency preparedness group, and I'm going to share with the Office of Climate Office, Tennessee Climate Office as well, to see if they have additional recommendations for this. Great, let's have our breakout room, and we do have our questions here. Like, what's your overall thought and perception? And what's the most important content that captured or missed in the dashboard? And how did you enjoy or dislike about navigation or visualization through the dashboard? And how should we promote this? Like, who should we contact? And who would be interested? Also, about the generative AI, how to apply in real life and maybe policy making and resources allocation. So, Aaron, could you help us assign the breakout room?
Yep. So I got the groups automatically assigned, the co-hosts I just assigned, and then you guys can jump into the rooms that you need to jump into, okay?
Okay, perfect.
So,
thank you. I'll see you in the breakout room.
All right, I just opened them up, so should be able to jump in.
Perfect. Thank you.
Yep.
I'm gonna be in room 2, maybe. Oh, you already joined. Someone already joined. I can join room 1 or 3. I'm gonna go to room 3.
Yeah, we'll go
Then
to the room 1, right?
Perfect.
Okay.
Right. Welcome back, everyone. I bet you guys all had a great discussion. Do we want to do some? Do we want? Wait, am I muted? No, I'm good. Okay. Let's do some quick reflection. Okay, so each of the group maybe can have someone who do a quick reflection of what we just talked about. Or do we have enough time, Jensen? Or do you want to move to next one?
Oh
I'm fine
yeah,
with it.
we have time. So yeah, you can do some quick.
Okay.
discussion here.
Okay, do we want to do like some 1 minute to probably reflection? Group one. Who's from group one?
Yeah, but they do you want to briefly talk about it?
Yeah, I can. So I don't know. Do you want to start to talk about it now, or we wait?
Yeah, go ahead.
Okay. Yeah, we had a very interesting discussions actually in group one. We enjoyed the like the multiple perspectives that have in one dashboard. It was very interesting to see that one problem was approached from different, let's say, perspective, and we had different data sources. And yeah, we were thinking, we had discussion about like, oh, why not having it in one place? Why all this data is not in one dashboard? Why we have like multiple dashboard? And then we realized like the Jeff actually had many inputs in this, where he brought the idea of like it's very hard to have it harmonized and all the data to play like in interpolation, and then we discussed that the one of the best value of the dashboard is its ability for people who have never used, let's say, GIS or has no information like geoinformation background can access easily and get so many informations in the dashboard. We were looking also for some additional, let's say, things. There is one thing that is done in the drought. There is what they call media drought index. So what they do is collecting like information from the media on the impact of drought, and we were thinking that something similar on flood would be also interesting. I mean, this is what I am able to summarize. Maybe Jensen can provide more, or Jeff, or Karen can also provide.
Yeah, you did ask. Thanks.
Great, group two.
So in our group actually, so we talk more about like the techniques, like about generative AI, rather than how to improve the dashboard. So yeah, I think Rob and other like members has helped a lot, like to introduce different kind of techniques, especially such as like data handling, how to like the challenges in cross like organization or sections, and how we can do the data standardization and promote data interoperability, and how we can use knowledge graphs and FAR and principles, and to build collections like among different like data sets, and how we can use maybe digital twin to integrate like Earth monitoring with some other social, scientific, and also community aspects to promote like the data processing as well as like modeling. And yeah, we also mentioned several like the other techniques about open knowledge network, and also like national climate assessment, and also system testing to consider the synthetic data for like system resilience like testing. Yeah, we also mentioned how we can like involve some real-time data and to promote like real-time like decision and understand like up-to-date like situation awareness, and how we can like prioritize relevant and real-time information for like response to improve decision making. So yeah, basically that's about more about like technical. Yeah, yeah.
That's great. Anyone in group three want to volunteer? No one want to volunteer? Okay. So in group 3, we did, there are a lot of great things that echoing your point and the group 1. We were talking about integrating things together instead of have all different tabs separately. So we want to combine everything and have query page for all features. We ask like maybe create a query page for each one, but that would definitely cause difficulty. But I mentioned we definitely will have one page that contains all information we have and have some query questions you can ask and trying to get the information. We do have someone who is very nice and say this is very easy to navigate and it's very user-friendly even with no experienced people. And we could add a more detailed description on some legend and variables we use. We do need to complete the metadata well. Who we should promote to dashboard. We could have some like city and local government and emergency response team and charity people and people who like in tropical areas who does all of those research. And we could when we talk about how to apply it in real life, we mentioned we could like providing assistance for the decision ready information. So it's we have the decision ready information and provided to community leaders or policymakers who can use this information to make decisions. And we also needed to be careful about the hallucinations. We also mentioned that, and which is a new word I just learned, making things up. So yeah, that's what we talked. Thank you guys.
Awesome.
And I'm
Yeah.
gonna pass it to Jensen. Yeah.
Thanks, Jen. Yeah, I think that is very useful feedback, Jen. That's actually what we're looking for. So thank you so much. Yeah, next is the paper idea. So I think we don't have much time left. It's like 15 minutes. So this paper idea is basically like because we are not asking people. I know a lot of people are like very busy and we barely has time to do all the things that we want to do. Especially when things come to AI, it's very time it's asking for it's a time demanding work. So as a cluster, as a community, I think the only realistic things that we can do together is writing a paper. And we can invite people to talk about it, but actually the action item we can do, and we can see the achievements is actually writing some like review paper or white paper together. So that's our plan for this year, for like next 7 months. And the question for you guys is actually pretty simple. It's like first is what paper idea you want to work on. Better centered on the practical AI, but if you have any other idea, because AI is actually a whole cycle, this whole system. There is a lot of non-AI technology is supporting AI. So if you want to work on those part, yeah, it's totally fine. Just to put your idea in the table. And then the second question is like, what do you think that practical AI products we are gonna make it happen this year? Because we're not talking about like in 10 years or 5 years. We're talking about this year right now. Because ChatGPT is already reality, right? It's already there. It's working. People are using it. I think the same thing probably will happen in Earth data science pretty soon. So we saw that a lot of effort from NASA impact developing the foundational models and all those like private sectors, Microsoft and Google Actually, NVIDIA is trying to develop another Earth digital twin, Earth 2, on their supercomputer. So a lot of things happening, and we should think about how we adapt. So yeah, that's actually the two questions. But if you want to talk about something else, just totally fine. Just up to you. This is just some like guiding questions for you. And we have a table. If you don't know what to talk about, we have a table listing the paper ideas in the meeting notes. So if you rooting for one of the tops, you are voting for one of them, just a plus one on that row. You can plus one on many topics if you want. You can have as many vote as you want. It just feels strongly that this topic is actually what I want to work on. Just feel free to emphasize that. And I think that's it. Aaron, could you just create a breakout room again, and we just
How many
maybe
breakouts would you like?
maybe 3. I think we have enough people to do 3 breakout room, right?
Do we just want to go back to the same ones, or do you want to recreate them?
Maybe recreate. I want people to shuffle and then meet new friends.
Okay.
So,
Great. All right. It should be open. Feel free to join in.
thanks. So the group 1, group 1, yes, Evan, Douglas, and Shirley, and we talk about like AI red list session in the morning, and also what topics we prefer. We didn't have a chance to talk about the practical AI products we're gonna say in this year, but yeah, that's pretty much it. It's like also, Douglas mentioned the reproducible AI, like the AI reproducibility is a big challenge. A lot of people have concerns about like AI research is not reproducible. How do you verify that actually you did it? So Stephen mentioned that reproducible AI is actually a little bit overlapping with the AI workflow management. So AI workflow management, it has the highest vote. I think yeah, most people agree that actually it's a big challenge. So that's all. Second group, anybody?
Okay. Group 2, we talked about some very interesting stuff actually. We talked about how to engage the community to promote the AI tool or how to use the AI tool. It's like we bring this tool to the community and see if they like it or they could use it or how to promote this. And the second one Karen mentioned, which I really like, is train people how to use AI and how to ask the right questions, which perfectly align with the discussion Jensen, and I discussed it before, that like generative ChatGPT is a very useful tool, but it's not that useful if you cannot ask the right questions. So Karen think it would be great if someone have some idea or a project to try to train people how to ask the appropriate questions. Yeah, and actually Jeff mentioned something, but his audio is cut off, so we cannot catch that part. But I bet his idea is great too.
Awesome. Yeah, actually, I have a lot of things going on about training people to use AI. Because ChatGPT is not going away. I think it stays, and a lot of people are asking all kinds of questions, and has no ability to tell what is right or what is wrong, or what is like misinformation, the fake things that you shouldn't trust. Yeah, I think tell whether AI is wrong is a very important ability for people working in the workforce. So we actually have some ideas in the proposal to like NSF, NASA about training people how to tell, how to like, judge the AI behavior, whether when you can trust, when you can just use the data, the answers when you shouldn't rely on that to make your decision or actions. But yeah, that's a lot of action. Yeah, just feel free to reach out, and if you're interested, just come to our machine learning cluster monthly meeting, and we can discuss more. Thank you so much. Group 3, yeah.
So, so in group 3, we briefly, so actually the ideas that we chose are kind of similar, including data AI, like data management strategies, and also AI workflow management. And so because we think it is kind of crucial for ensuring the scalability and reliability as well as the reproducibility, like in AI-driven like applications. And so in the last, we also mentioned like how the community, how we can introduce like AI tools in different kind of communities with different needs. However, the main challenge is that so how we can maybe train some tailored like large language models to different kind of communities, but data security and is kind of issue because they may have a kind of concern whether like the model is kind of reliable or whether it's kind of safe to share the data with others beyond the community. Yeah. So yeah, basically that's what we have discussed.
Cool, awesome. I think that's all. What else do you want to discuss? Or anybody has any questions before we wrap up? Awesome. All right. Yeah, don't forget to put your name and email. Actually, put email in the meeting notes. And yeah, if you're interested, we can send you some follow-up emails so you can just get engaged into our community activities in the coming half year. And hope to see you all in summer. So in one of those activities. Thank you so much, and have a nice day.
Thank you.